Hello everyone. In this video I am going to tell about Markov chain and its applications. A Markov process is a stochastic process that satisfies the Markov property. In simpler terms, it is a process for which predictions can be made regarding future outcomes based solely on its present state, and most importantly, such predictions are just as good as the ones that could be made knowing the process's full history. In other words, conditional on the present state of the system, its future and past states are independent. Types of Markov chains. Discrete time Markov chains. This implies the index set T is a countable set here, or we can say that changes occur at specific states. Generally, the term Markov chain is used for DTMC. Continuous time Markov chains. Here the index set T is a continuum, which means changes are continuous in CTMC. Properties of Markov chain. There are four properties of Markov chains. First property, Markov chain is said to be irreducible if we can go from one state to another in a single or more than one step. A state in a Markov chain is said to be periodic if returning to it requires a multiple of some integer larger than 1. The greatest common divisor of all the possible return path lengths will be the period of that state. A state in a Markov chain is said to be transient if there is a non-zero probability that the chain will never return to the same state, otherwise it is recurrent. A state in a Markov chain is called absorbing if there is no possible way to leave that state. Absorbing states do not have any outgoing transitions from it. This is the code to check whether a given matrix is a Markov matrix. This code is using C++. You can execute this code in Genie compiler or any online GDP compilers. These are the variables to declare, and this is the code to execute whether the matrix is Markov matrix or not. This it is the input when we give the matrix 1 0 0 0.5 0.5 and 0 0 1, then the output comes as yes, it is a Markov matrix because sum of each row results to 1, therefore it is a Markov matrix. Assumptions for Markov matrix. The statistical system contains a finite number of states. The states are mutually exclusive and collectively exhaustive. The transition probability from one state to another state is constant over time. Markov processes are fairly common in real life problems, and Markov chains can be easily implemented because of their memorylessness property. Using Markov chain can simplify the problem without affecting its accuracy. Let us take an example to understand the advantage of this tool. Suppose my friend is suggesting to have a meal. I may say that I do not want a pizza as I have that 1 hour ago. But it is appropriate if I say that I do not want a pizza because I have it 2 months ago. That means in this case my probability of picking a meal is entirely dependent on my immediately preceding meal. Here is the effectiveness of the Markov chain. These are some applications of Markov chain. Markov chains make the study of many real world processes much more simple and easy to understand. Using the Markov chain we can derive some useful results such as stationary distribution and many more. Markov chain Monte Carlo, which gives a solution to the problems that come from the normalization factor, is based on Markov chain. Markov chains are used in information theory, search engines, speech recognition, etc. Markov chain has huge possibilities, future and importance in the field of data science, and the interested readers are requested to learn this stuff properly for being a competent person in the field of data science. Thank you.